Do you want to solve real and difficult problems? Projectile motion problems with just a protractor and a ruler, maybe a little calculator? Well, this is how to do it. No trig, no algebra. That's all you need. Real problem, no trigonometry. Where do I put that can so the ball lands in it? Let's learn physics. Now, my students take a known velocity and calculate the position to place this can on the floor, on the table, depending on what their assignment is, and make it in just one shot. You drop it in there in one shot, that's 10 points. You miss, that's a 0. All or nothing, for real. Let's do this. I think I can do it using this method, which uses the equation delta x is equal to VIT plus 1/2 AT squared, but doesn't use any of the trigonometry and doesn't use the two separate x and y columns and doesn't do any of that stuff. It treats this as a basic vector equation. Start out with the known initial velocity of 6.55 meters per second and it's chosen 50 degrees above the horizontal. I'm going to multiply the whole scale, everything by 4. This is a displacement diagram. So measured 85 centimeters in height. That's 3.4 centimeters on the diagram. Make sure my pencil's all sharp, because otherwise I get problems. Measured from the bottom line, that height, and then measure from the initial launching point, 50 degrees, and 50 degrees above the horizontal, imagining that that thing just keeps on going forever. That's the VIT part of the equation. Extending it onto a second page because it's really big. That line is the VIT line, assuming a constant velocity. So mark off 1 second, 6.55 meters in that second, multiplied by 4 to get the distance, and then do the 1/2 AT squared. The vertical displacement from that 1 second position would be 1/2 times 9.8 times 1 squared. Gives you that distance, and it hasn't quite reached the ground yet. So let's do another calculation, maybe 1.1 or 1.2 seconds. Back to the VIT line, 6.55 times 1.1 and 1.2. Multiply by 4 for the scale, and you get two new marks at 1.1 seconds and 1.2 seconds. Then drop the verticals from there. 1/2 AT squared for the two of them. And it ends up that at 1.1 seconds it's above and 1.2 seconds is below. So it's maybe 1.17, 1.18 seconds. And here's where you just approximate. It's close, right? So it looks like it's about there, that little asterisk thing. Then you measure the horizontal displacement, 19.5 centimeters, and then divide that by 4 to get 4.875 centimeters, or actually meters in this scale. Let's set it up. See if we can make it in that one shot. Set the projectile launcher at 50 degrees. It's going to launch from that position. And measure the whole thing out. Drop some meter sticks on the floor. Use a tape measure, whatever. But get that 4.875 meters all measured out. Place the bucket at that exact position. And then push the meter sticks out of the way once you get it at the right place. All right, we are set up and ready to go. Going to shoot the ball. 4.875, which is 4 7/8 meters. See what happens. Ready? All right, so looking to shoot it in the can. One shot, that's it, that's all I get. So, okay, this thing has 3 settings. That was the minimum. That was just a good time. All right, let's do it right this time. Actually load the thing up properly. Never let anybody else load your cannon. 50 degrees still? Yeah? Okay, pretty close. All right, a little bit nervous. This thing in one shot with no algebra, no trigonometry, no components of vectors. Everybody can do this. If you can use a ruler and a protractor, that's all you need. Forget the trigonometry and algebra. You don't need it. This makes real projectile problems accessible to everyone. If you were paying close attention to that video, because I didn't realize it until I went home to check it out, I actually measured a 4.775 and not the 4.875. But that's one of the reasons why you build in success into this model by using a tiny ball and a massive bucket. Because I remeasured to 4.875 and it made it too. So there is a range of distances. You can put this bucket, it'll still make it. Worked out pretty well. Really great quiz. And this is a much better method. Thanks for watching Learn Physics. And thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.